Okay, today what we're going to do is we are going to look at some practice problems using the electrical laws that we talked about, namely Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law. So the first problem we have is this circuit here. Now, of course, the first thing that we're going to do is we're going to make a nice, neat chart that's separated by columns and set up in Ohm's law format. And we're going to go ahead and add the resistor values to that column first. And this is nice setup because if we have 2 out of 3 items in a row, we can calculate the third with Ohm's law. But if we take a look at this circuit, we can see that we have 2 loops here. So I've got one loop that's here, I've got a larger loop that's here. Because of those loops, I can basically say that each of these resistors has the same voltage as the voltage source. So the voltage here for 1 is going to be 12 volts. And the voltage for 2 is also going to be 12 volts. Okay, so that basically leaves me with calculating the current. So all I really need to do to calculate the current is use Ohm's law. V equals IR. So what I'm going to do is I'm going to reformat that to say I, and I'm going to say 1 equals V1 over R1. And I'm going to go ahead and type in my numbers, 12 over 100 ohms, and that's going to give me 0.12 amps. And I can go ahead and fill that in my chart, 0.12. And I can use the same principle to find the other current in the other branch for R2. So I'll basically recopy that equation, I2, except I'll use a subscript of 2 instead of 1, V2 over R2, and I'll fill in my values. We'll have 12 over 200, and in this case, that's going to give me 0.06. And I can fill in that value on my chart, 0.06. And that completes our first problem, okay? Going on to the second problem, I have a single loop here, and I have resistors that are in one loop. Now, if I take a look at this, I can use Kirchhoff's voltage law to find the voltage first. And I know that voltage drop is proportional to the resistor value. So since I have 2 resistors in one loop with the same resistance, I know my voltage is going to be cut in half because these 2 voltage drops have to add up to 6. So that makes the calculation of the voltage very easy. So that's going to make this 3 and this 3 as well. And again, just like I did for the first problem, I can use Ohm's law to find this third value because that's the last thing that I have, V equals IR, and I'm going to solve for I. So in this case, I'm going to say I1 equals V1 over R1, and I can put my numbers in, and I will have 3 over 100, which is going to be 0.03, okay? 0.03. Now, since this is a single loop, I don't have to do the calculation. I know that all of that current is going to pass through this one here. And if I do the math anyway, you can see that it checks out, 0.03. That is the second example. Moving on to the third, this gets a little bit more complicated, okay? So here I have a current source. I do not have a voltage source. So what I have to do is I have to look at Kirchhoff's voltage law. Sorry, Kirchhoff's current law. So all of this current here is going to pass through that first resistor. So I'm going to go ahead and fill in that value, 0.15 amps. Since it's 150 milliamps, it's 0.15 amps. Now, I know that once it gets to this point right here, and then let me draw a dot here on the screen, once it gets to this point right here, that current is going to split. So it's going to split unevenly. Since this resistance is lower, more of the current's going to pass through the second branch than it is on this third branch. So I can kind of use a ratio of the resistors to help me figure that out. So my I2 is going to be a percentage of my I1. So I'll say I1, which in fact is I total. And for my resistor, for my ratio, I'm going to take the larger resistor and put that in the numerator. And then in my denominator, I'm going to take the sum of the two resistances, okay, because that represents the total. So that'll be 52. So if I go ahead and let me put this in conceptually first, that way you can kind of see what I did here. R2 plus R3, and then we'll substitute the numbers in. So I got 0.15 times, let's see here, 30 over 52, okay? All right, so I've got my ratio that's there, and I'm gonna go ahead and do my math, and that is gonna end up being 0.086. So I'm going to go ahead and fill that value in here in my chart, 0.086. Now the way my chart's set up, it's very nice because I have my total current in that first row. I've got most of my current going here. So rather than doing this same calculation again, what I can do is I can just subtract it because I know that my I1 is going to be equal to I2 plus I3. So what I can do is I can go ahead and solve for I3. That's going to be equal to I1 minus I2. So if I go ahead and do my subtraction, which my chart is already set up for that, and that's going to end up being 0.064. Now, since I've got Ohm's law here, I can go ahead and find out using my multiplication, Ohm's law, figure out what my columns are here. So that's going to make that a lot easier to do. So I can use Ohm's law to find the other values. So in the first column, my voltage is going to be 0.15 times 10. And as you know, that's a very easy very easy multiplication problem. It's going to end up being 1.5. So I can go ahead and fill that in the chart. Now using Kirchhoff's voltage law, because I can cover up either one of these resistors to make a loop, these voltages here are going to be equal. So they are going to end up being the same. So I can calculate one and then go ahead and fill that in for the other one. And if you want to calculate the other one, you'll see that they'll end up being exactly the same. So we've got V equals, in this case, 0.086 times 22. And that ends up being about 1.9. Okay, so I'll fill that in, and that's rounded, and I'll fill that in here. And then we'll be all finished that problem. Okay, my very last circuit problem is here. And again, filling in the resistors first in the column that goes here. And I take a look at my circuit. I have two loops, okay? I've got one loop that's here, and then I got another loop that's here. So I can use Kirchhoff's voltage law to help me find out the voltages and then calculate my currents afterwards. So if I take a look at this first resistor, since there's only one resistor in that loop with the voltage, I know that that voltage, and that can be 120. Now, if I take a look at these two voltage drops across each of those resistors have to add up to 120. So we can go ahead and write that down as a note if we like to. So we can say V2 plus V3 have to add up to 120. And since the voltage drop is proportional to the resistor size, and these resistors are equal, we can assume that the voltage drop is also equal. So if I take 120 and divide it by 2, I get 60. 60 plus 60 equals 120. So I'm going to go ahead and add that into the chart here. Okay. Now the very last thing I can do, or that I have to do here, is find my current. And since I have 2 of my 3 values, I can use my Ohm's law calculation to do this. So I've got V equals IR, and then I can solve for I equals V over R. I substitute my value in for the first column, and then I've got 120 over 100, which is going to give me 1.2 amps. So I'll go ahead and fill that in here. And I can do that same calculation for the second row. V equals IR, but I'm solving for I in this case. I equals V over R. And I'm going to go ahead and take my 60 divided by my 200, and I get 0.3 amps. And I'll fill that in my column here. Now, I know that since these resistors are in series with each other, the current has to be the same. So if I wanted to, I could calculate that value, but I can just fill it in here because of that concept there. And that's it. Hope that helps.